Okay, everybody, new unit. Moving on to unit 5, which is chemical bonding. Okay, so what we want to do is get an idea of taking elements now. Now we know their electronic configurations, and we know what we're talking about with the periodic table. And we're going to let elements go out of their comfort zones and let them go and bond. Okay, so when we do that, some interesting things happen. Can we predict it? Can we figure out how bonds actually go out and form compounds? So this is a little bit of a long road. There's a lot of information in this unit, so you want to take things in little doses. Okay, and please ask questions. Make sure you're going along the way and come into class with questions. All right, so first, chemical bonding. All right, atoms of elements join together by forming these things called chemical bonds. Okay, and we'll go into what a chemical bond is and and things that make it up. Okay, this can happen in many ways. All right, understanding how bonds form and break can help scientists create a lot of new things for medicine, technology, new products, new ideas, new surfaces, all different types of natural things, but also figuring out what nature does and also figuring out how materials actually behave. Okay, so what is a chemical bond? Really, what a chemical bond is, it's a force of attraction, okay, between the nuclei of one atom and the valence electrons of neighboring atoms. So it's a mutual attraction. So really, the nuclei are involved in attracting the electrons of some other element. Okay, and again, this can happen in a variety of ways. We're still trying to uncover how bonds form. Okay, now there's a couple of reasons why bonds form. One of the reasons is to decrease the potential energy. Okay, again, elements generally want to become more stable. Okay, and they want to decrease their internal energy, their potential energy, by releasing energy. Okay, and you increase the stability by achieving a stable electron configuration. Sometimes this is our stable octet. Again, we talked about an octet. Typically, an S2P6 is becoming a good guideline for stability. All right, it's not always true, but this is a good guideline. All right. Now, once you form this bond, okay, you then create some type of structure of the atoms. And again, like we've heard this in biology, where the structure eventually determines the function, okay, of what this element can do. Okay, but the important thing is all here that the bonding would then get the structure, and then that would determine the function. Okay, so this is going to determine the chemical and the physical properties of something called a compound. And remember, a compound is the union of elements to form new things, two different elements, at least two different ones. Okay, another guideline you want to remember also is that compounds are going to have different properties than the non-bonded atoms would. Okay, and again, we're going to see this along the way. All right. So again, so let's take a little bit of a closer look at the energy value, okay, or the energy that takes place in bonds. And again, we've done this before in the energy unit, but we want to look at it again quickly here. Is that if we look at, hydrogen atoms, sorry, a hydrogen molecule and a chlorine molecule, we're going to put them together. We're going to form a bond, HCl. Of course, we're going to have to break these two bonds first, right? We have to break the HH bond. We have to break the Cl bond. Okay, so when you break these bonds, of course, you guessed it, energy would have to be absorbed to pluck these two guys apart and pluck those guys apart. All right, when these two bonds are made, when the new bonds are made, okay, energy will be released, okay, to form a more stable compound, HCl. Okay, so energy released, again, it would be released on the right, okay, released on the right side of a reaction, shows that it's, you guessed it, exothermic. Okay, so it's going to be exo. Okay, and again, it's the balance of absorb and release. So in this case, more energy is released than absorbed in this reaction as a whole, and that's why what we see overall is energy. That's on the right side as far as exothermic. All right, so important to know about that too. So again, bonds broken, energy is absorbed. Bonds formed, energy is released. Again, we want to remember that along the way. Okay, in chemistry, typically what we do is we use the term bond energy. Okay, if you think about, if we go back to the periodic table and we think about ionization energy, is the energy needed to be put in to remove an electron. Well, bond energy is almost the same idea. It's the energy required to break a chemical bond. So if you want to pull two atoms together, apart, I'm sorry, you would have to put bond energy into it. So for example, if you have, Na and Cl, and you want to break that apart into Na plus Cl2, you'd have to put energy in to break that apart. So that would be bond energy. Okay, and what scientists do is they use that as a tool, the energy value, to treat to see how strong a bond actually is. So high bond energies, okay, indicate very strong bonds. Again, if you need a lot of energy to break up a bond, then that means that the bond is very strong. If you've tried to take apart, a jar, if you try to open a jar of pickles, for example, and you had to put a lot of force to open up that jar, you know that that top is on very tightly. If you tried to pull apart two pieces of wood that were very, 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 very strongly screwed or glued together, you would have to put a lot of energy in to separate them. All right, so that's how you do. So, for example, if you have a CH bond, these are your bond energies here. So the bond energy is here. Okay, that means you'd have to put 413 kilojoules to break that bond. Where if you had a double bond, you'd have to put 495 in here, right? And if you had a triple bond, the nitrogen triple bond, you'd have to put, 941. So what does that tell you here? So which of the molecules here would have the strongest bond? Provide the evidence. The evidence is your bond energy. Okay, so the nitrogen triple bond is strongest. Okay, because the bond energy is the highest. Okay. Now, also good to know is that N2, which is N2 is 78% of air, right? It's 78% of the air. We can do nothing with this. When we breathe this in, we simply breathe that back out N2. The body does not have enough energy. We don't, in our own bodies, humans don't have a way to apply this amount of energy to separate that bond. So nitrogen, we breathe it in, we just breathe it out without being, affected. All right. So really, what I want to do here is just show the different types of bonds here. Okay. And what we want to do is just go through a general list here, and then we'll look at everything individually. So the types of bonds, the first type of bond is something called covalent. Okay, covalent, co means to share. Valent means valence electrons. Okay, so valence electrons here. Okay, and again, you're going to be sharing electrons between two or more atoms, and we're going to form molecules. So here we go. We're going to start getting some terminology here. So be ready to go. Okay, so only covalent bonding has these molecules where you the individual covalent units. Okay, really important about covalent bonding. Okay, is an overlap of these orbitals. Okay, so the electron cloud. Okay, so let's just say you have a hydrogen atom with one electron, another hydrogen atom with one electron. They see each other across the dance floor. Okay, this nucleus begins to attract that electron. This nucleus begins to attract that electron, and we start to bring these two atoms together. Okay, they come together. This guy comes together and forms this. This guy comes together to form that. We get together. We begin to mix our electron clouds. All right, and eventually we bring these electrons cloud. We have an overlap of orbitals. Okay, where this attracts to this guy, this attracts to this guy, and then we end up having the situation where we share a pair of electrons between the two atoms. So what we're thinking is that you started off with a 1s1 and a 1s1, right? And now you have a 1s2 in the middle that both atoms share that pair. Okay, and then we can take that pair and we can make it a line. So the line represents that 1s2. So think of about the box here and a box here has a shared 1s2 between both atoms. Both atoms would share that 1s2. Okay, so again, this would be the nucleus of H. That would be the nucleus of the H. And now this is a new unit of H2. Okay, so that's important to know about that. Now, in an ionic bonding, we get a transfer of electrons. It's a little different. Okay, the mode of forming the bond is slightly different, where we're going to take electrons from the metal to the nonmetal. So you're simply going to take electrons from the metal, and they're going to be transferred from the nonmetal, because the nonmetal has a very high electronegativity, okay, and the metal has a very low electronegativity. So you're simply going to follow that electron around. Okay, so electrons will flow from the minus charge from the the metal, which is here. The electron will flow in that direction. you'll get two positive, and you get a positive ion and a negative ion. Again, this would be the nonmetal here. Okay, and lastly, the third type of bonding. Okay, if you have nonmetal, nonmetal, again, we can make that argument here. As far as if you had nonmetal and nonmetal bonding here, okay, and you have metal, nonmetal bonding here, then you can make an argument for metallic bonding, which is just bonding with metals. Okay, and this is going to be a special type of bonding that occurs between only metals. All right, and we'll hit that at the end between just metal atoms. Okay, and this becomes a sea of electrons, sea of mobile electrons. Again, we'll get to that towards the end of the unit. Just when you can't take it anymore, we'll do this. So really, there's three types of bonding. And what we're going to do is we're going to hit this type of bonding first. We'll hit this type of bonding second. We'll hit this type of bonding third. Okay, I think we'll do that because there's so much more to do in sharing. Sharing is caring, and sharing has a lot to do because you can share evenly or unevenly. You can form different types of molecules where ionic bonding is kind of one-dimensional. So we'll do that first. So buckle up. Make sure you review this. Make sure you know the three types of bonding. And we're going to get set with the next lesson on covalent bonding first. Okay? Enjoy.